And they were adamant that their I/O load was being the disk subsystem was being driven flat out. And after a number of months of trying to reproduce this, the same sort of large config, Chris went to site and just ran I/O stats and said, you know, go and start your workload. Have you started it yet? And they said, yeah, we started it long ago. And there was no I/O going to the system. Or it was all cached. And the tipping factor here to find this corruption that had been occurring on the disks was that when the drives, this particular make of drive, was idle, it would go into housekeeping and then confuse where the block of data should be written. And once they knew that idling was the key, it was reproduced very, very quickly. The disk vendor produced a firmware fix. And that was kind of one of the unexpected things we've typically associated problems with heavy workload, but sometimes they can be associated with just stopping and different operations kicking in. But the fact that the sort of good practice here was the customer was adamant the load was a very high I/O load, and that kind of misled us. Maybe something we should have checked earlier. So Rob Hume was my director until about a year ago, and he's the senior director of services support for the operating system for Solaris, worldwide. And I said, what good practice? And he said, well, one thing that the underlying thing, the most common thing for him to be called onto a customer conference call is not a particular issue, but it's where the customer can't restore their environment. And the two cases he cited, and these are the ones where he'll have been woken up in the middle of the night, was that customer A patched in multi-user, do that, end up with a boot archive that was corrupt and couldn't restore their machine. Better alternatives available, and really here we're talking about ZFS snapshot and live upgrade. And his message really is that these technologies are there and they can save a lot of hassle. And the other one that he cites was the administration system during the peak, for a US university during the peak of their admissions period. They decided to upgrade kernel patch. However, there was a third-party driver which used an unpublished kernel interface, so not our fault. And after they reboot, after applying the kernel patch, they couldn't see their storage. Because this driver wouldn't load, used a function that was no longer there. And involved a messy rebuild and restore. And this was found on the second hit on Google. So knowledge was out there. But again, they could have had that problem, but if they'd used snapshot and restore, they'd have been able to recover from that. And it really is assuming the worst. And these are now mature technologies. I guess we just wonder sometimes why they're not used. I'm sure many of you will come across Jerry Haskins, who's was I think director of patching, but now director of lifecycle technologies. And he does a really good job of getting information out there with these two blogs. He started a Solaris 11 one as well, about the life cycle. And Chris is about to pull the camera over.
No, not.
Oh, no, I think we must come on. So, sometimes, as operating system vendors, and this is true of any operating system vendor, where you come from, we kind of get things wrong. So, this is an example, and I know this has hit a couple of customers, is that Solaris 8 MDB came out. Prior to that, MDB is a kernel debugger, so it's for us to look at kernel failures. And also it has a facility to patch a live kernel, so we can change the kernel as it runs. So there was a predecessor to that, was called ADB. And the behaviour of the two is different, or was different. And so a support engineer, I don't think it was mod debug, but let's assume it is. So this here, mdb minus kernel, k, w, means we want to write. And so mod debug, we want to change the value of mod debug with the /w to 1. Great. If that's what you wanted to do, maybe get some debugging output as modules load. And what the customer then did was type exit. Okay, that's kind of intuitive. Okay, but what MDB does that was different from ADB is it repeats the last command. So exit, the system call, got replaced with a value of 1, which means the next process to call exit will try and execute a function at address 1 in kernel context. Boom. Okay. So I know there's a couple of customers here. You can get the issue doesn't exist where you use this. So the first step was to update some of the knowledge documents that showed you how to work around a particular issue. And this was used in a workaround. So if you can imagine a customer had an outage, they're given a workaround, it didn't have complete information, causes another outage. So to fix this, and I fixed this a couple of weeks back. In fact, I fixed it last Monday in Solaris 11 Update 1, and it is being patched back to Solaris 10. But this is kind of an example of a gotcha. It was only 10 lines of code, and it was just something that we kind of not got around to. And I think the good practice here is if you come across something like this, hassle us to fix it. Log a support case, email me, whatever. But I think it is a good practice to avoid these. This is it, a few people. So I think another area that's often neglected, and this is getting more important as time goes on, from a performance point of view, is firmware. And if this is frequency of firmware release, and this is time for a particular platform, the frequency of firmware release kind of goes like that. So you start off with firmware being, new revisions of firmware for a platform being released quite frequently, and then the time period between releases extended significantly. So, some time ago, maybe about 9 months after the T3 had first shipped, I was asked to look at a performance issue, and I couldn't make head nor tail of it. This MP stat, IO stat, any of the compiler tools gave me no insight into why this application would not run well on a number of T-series machines. And what I did was take an Explorer from that T-series machine and ran it through one of these processing tools. And the only noticeable thing that it came up with was, your firmware is out of date. Might as well try that. So I did, and the application ran 4 times faster. And if you go forward 2 years, a year or two again, next range of machines, T5440, had the same issue, the same experience, different application, different bug. But for machines like the T-series, and the M-series, and for x86, firmware is becoming thicker. There's more operations taken care of in firmware. And it's becoming, it's very difficult to observe. We have very poor tools to observe, certainly at outside the engineering context, to observe what's performance issues. So, we can diagnose them once we know they're there, but it does suggest that a best practice is actually keeping some way, being very aware of the curve of firmware, particularly on early machines, and that firmware is thicker than it used to be, and more services and dealing with error handling, memory layout is being taken care of in firmware rather than the operating system. Right, so this particular good practice, I don't get many jollies. So a director kind of rings you up on a Friday morning and says, can you find yourself in Johannesburg tomorrow morning? All right, I'll try to. And this particular customer had bought 3 25Ks and they wanted to put them in the car park on Monday. So, okay. Now what I found was that they had a COBOL application which talked to an Oracle database, and the key thing here was that if you take the round trip time between two zones on the same 25K for a packet that's going to the Oracle database and coming back, that is about 50 microseconds. If you go over Ethernet, then it's about 200 microseconds. And the customer had said, I later found out we'd offered the customer architecting solution or architecting services. And they said, no, we'll do this ourselves. So previously their workload had run on a Fujitsu box and run at N. And on their initially architected solution, it had run at 1/4 of N. And when we moved the database and the application back into the same sort of physical container, but separated by 2 zones, we got all of our performance back. And this seems, I could recount a couple of similar stories where the customer hasn't taken into account the speed of light, and it's gone to very upset executives. But the original customer conclusion was that the E25K must have slow CPUs. And even when I kind of drew this out on a whiteboard and said, well, if you're going over this piece of Ethernet, it's going to take you 200 units of time. If you go internal, it's going to take you 50 units of time. They still couldn't quite believe it. But this is quite common amongst our less tax savvy. Nice thing was though, they had a power down over the weekend, so I went to the Pillansburg National Park. Don't get many jollies, I have to say. So and I think what this does in a way highlights maybe a gap in tool support, but it's about opening your mind. I did some work, and this is probably about 5 or 6 years ago, with a large UK bank. It's not as large as it was. On a SaaS risk management, do we give people loans? Do we give people mortgages? And they processed many terabytes of data in that day. And the application was completely I/O bound. 90% of the reads and writes went to some temporary files that SaaS had created. And these had no persistence requirements if the machine was powered off. Those files were completely, the run would have to start again. So there was no persistence requirement. So in effect, I worked with them for a couple of days, gave them the options, explained what was happening, and say, well, what would you choose to do? You know you have about 500 gigabytes. Remember a few years ago, 500 gigabytes was a lot. Would you choose to refresh all your 10 terabytes of storage at a cost of £2 million? Or would you put your SaaS temp directories on fast local storage, about 35K? Or would you choose to put your SaaS workspace temp directories in memory? Who would choose A? Who would choose B? Who would choose C? Who would let somebody else make a choice? Oh, right, okay. And the speed, they made one of those 3 choices, and they got about a 5% speed up. And you think, oh, I told you so. They chose that, of course. Now, the interesting bit here for me was it highlighted how difficult it was to work out what the working set of an application is. So how much memory did we actually, how big was the working set of all the files that were accessed? Because you might be